So you have your notebooks out, you ready to go? All right, chapter 4. Now the thing with chapter 4 is we are going to do 4.1 and 4.2 before the semester, but when we get back after the semester, you're going to be required to know 4.1 and 4.2 like going forward. Okay, they're very important lessons, and they're things that you have to know for like the rest of calculus. Okay. All right. So chapter 4 is called. You're going to love this. Chapter 4 is called More Derivatives. I'm not kidding you. No, but it's funny that they call it that. This actually, back in the old book that I used before this book, this is my second calculus book I've used. The old book had chapter 3 went all the way to 3.9. Yeah, so we just finished 3.5 was the last of the chapter, and then chapter 4 was part of chapter 3. It was so long, so I'm glad they split this up. All right, so here we go, 4.1a. Trevor, Josh, you guys ready?
Yeah, we've been ready.
Because I don't want Sophia to have to yell at you again. You know, she's getting real tired of it. No, I care.
No, I really am.
I know. All right, chain rule. Chain rule, very important thing. Okay, so here's the thing. You know the derivative of sine x. I mean, I hope you do. You just took a test on it. And you know the derivative of x squared minus 4. Okay? But what happens when we have a composite function? Composition of functions, remember f of g of x, the fog, little circle? Yeah, so what happens when we have the sine of x squared minus 4? How do we take the derivative of that? That has two functions in it, okay? You can't just take the derivative. No, there's going to be a rule. So I wouldn't even guess it. It's crazy. It's going to be a rule. So here we go. This is called the chain rule. So if f of x is equal to h of g of x, and you could have more than just two functions, composition of functions. You could have like 3 and 4, and then you have to do the chain rule like 3-4 times. It's crazy. Okay. This is called the outside-inside rule sometimes. Some people call it that. So if you want to take the derivative of f of x, this is what you do. You take the derivative of the outer function first, leaving the inner function alone. And that's what people will do. They'll take the derivative of the outer function at the same time as the inner function, but you don't. So you take the derivative of the outer function, and then you multiply that by the derivative of the inner function. And that's chain rule. Okay? And we're going to see it in action. We're going to do a bunch. So that right there is chain rule. It's all chained, it's all linked together. They get all linked up. So let's do that one then. Number 1. So these are all just find the derivative. We're just finding derivative. We're not even putting in applications into this yet. Okay. So let's say we have y equals the sine of x squared minus 4. And we need to find y prime. All right, with these I like to kind of step back and look at them and go, okay, how many functions do I have because how many chain rules am I going to do? How many chains, like links, am I going to have? I have 2 functions. My outer function is the sine function, and then my inner function is x squared minus 4. So I have 2 functions here, okay? So I know I'm just going to do it. I'm going to do the chain rule pretty much like one time. You can think of it as one time. It's going to take 2 derivatives, though. All right, so this is what you do. You take the derivative of the outside function. So what's the derivative of sine? Cosine. And then you leave the inside alone, okay? You don't change the inside at all. You're taking one derivative at a time here. Take the derivative of the outside, leaving the inside alone, and then you multiply by the derivative of the inner function, which is 2x, and that's it. Okay? And usually you put 2x on the front, cosine x squared minus 4, and that would be your answer. Okay? All right, let me show you. Number 2, chain rule like this. Let's say that f of x equals 3x plus 1 to the 4th power. Now, you could technically use Pascal's triangle and the binomial expansion theorem and expand that. Remember that? 1, 4, 6, 4, 1, blah, blah, blah. And then you can take the derivative of all that. But we can use chain rule here instead, so we don't have to do all that, okay? So we're going to take the derivative. There's an outer function and there's an inner function. There's 2 functions going on. The outer function is the fourth power. It's like x to the fourth, okay? The inner function is 3x plus 1. So this is what you do. To take the derivative, we're going to think of this as something to the fourth power. So we're going to bring the 4 down, leave the inside alone, and subtract 1 off. Okay? So far so good? Yeah. Then times the derivative of the inside, 3. Derivative of 3x plus 1 is just simply 3. So our answer would be 12 times 3x plus 1 cubed. And you don't need to cube that out and distribute the 12, and you're done. And that's it. Okay? Chain rule is a beautiful thing.
So where's the card?
Oh, it will. Pretty soon. Number 3. Get to that? Wow, you guys are crazy. All right, how about y equals sine to the fourth x? Now, for these, they don't look like you're doing chain rule here. It's just like, what's the inner function, what's the outer function? So a lot of times when it's written like this, you know, cosine squared x or sine squared x or whatever, you can rewrite this as the sine of x to the fourth power, okay? Because that helps. That shows you that there's two functions going on. There's raising to the fourth and there's sine. So now let's go ahead and do chain rule for this. So y prime equals. So the outer function, just like the last one, instead of 3x plus 1 on the inside, it's sine x. So the outer function is to the fourth power, so I'm going to bring the 4 down, leaving the inside alone. People want to take the derivative of that right away. You don't.
Can we write sine 3x?
Yes, yeah. And then times the derivative of sine x, which is cosine x. And that's it. And you can leave it like that, or yeah, you could write it as 4 sine cubed x cosine x. That would probably be better. That's probably what the book will do. Okay. All right. How about, ooh, here we go. Here we go, Trevor. You ready?
Yep.
You've been asking for some harder ones. Here comes the harder one. Let's say you have y equals cosine squared of 3x. Okay. This doesn't look that bad, but it is. This one has 3 functions going on. Okay, this is our first multiple chain rules that we're going to do. So this right here, I would rewrite this as the cosine of 3x, and this whole thing is squared. Okay? Now, can you see what the 3 functions are? The outside function is the squared, and then there's an inner function, which is cosine, and then there's the innermost function, which is 3x. The innerest, if you want to say that, yeah. Okay, so here we go. Are you ready? Just remember, when you take the derivative, you're only taking one derivative at a time. This one we're going to have to do a couple links, though. So my first thing I want to do is I want to take the derivative of this power function that's being squared. So I'm going to bring the 2 down to the front, leaving everything alone. And then it's to the first power, right? Don't forget to subtract 1 off, but it's just that. Okay. Times, now we're going to take the derivative of cosine 3x. The derivative, but we're not doing anything with the 3x. We're leaving the 3x alone. So what's the derivative of cosine? Yes. Negative sine 3x. And then finally, take the derivative of the inner function, which is 3. And then go ahead and simplify everything. So I've got a 2 times a negative times a 3. It's all linked. It's just chain rule. It's like a chain, you know, and it's all linked together. It's all multiplication. So this is negative 6 cosine 3x sine 3x. And that's your answer. Okay. Let's go one more. Last one. We have time. This last one is going to involve chain rule and product rule. We could have chain rule plus the quotient rule. We could have them all mixed up. And at the end, when you're going to be able to find the derivative of anything, you're going to be so good at these. All right, x squared times 3x plus 4 to the third power. All right, so there is a times here. They don't usually put the times there. It's nice to kind of just put it in to go, okay, I have 2 functions here, right? My first function is x squared, and my second one is 3x plus 4 cubed. Now, x squared is a very simple function. There's no chain rule going on there. But this, there's going to be chain rule happening on this one, okay? All right, so we're going to take the derivative by doing a times b prime plus b times a prime. So let's do it. A is x squared times b prime. So b prime, this is chain rule. We're going to bring, we have an outer function, which is a cubed function. We're going to bring the 3 down to the front, leaving 3x plus 4 alone. Do not forget to subtract the 1 off of there. That's another thing people will do on accident. You know, you don't mean to do it, of course. But when you bring that 3 down, you still have to do the power rule of subtracting 1 off. And then times the derivative of the inside, which is 3, plus. So that's just the first part. That's a times b prime plus b times a prime. What's the derivative of x squared? 2x. Okay, and there's not much to simplify on these a lot of times, but let's get the 3 times the x squared. So that's 9x squared times 3x plus 4 squared. And never feel like you need to FOIL anything out at the end or, you know, use cube all that. You don't need to do that. You just leave it just like this. And that would be it. All right. Okay. Oopsie woo-woos. Cubed. Okay. Thank you.